Good morning everyone. I've had a few questions about RGB, CMYK, so on and so forth. So I thought I'd take this opportunity to sit out in the back garden in the beautiful sunshine, drinking cups of tea from my in reverse Epson cup that I stole from Epson on an engineering course. Shh. And tell you why we use RGB. Right. First of all, RGB as opposed to CMYK, where did it all come from? As you know, one's like a transmitted light, if you like, and one's a reflected light. When it comes to monitors, when it comes to print, however, CMYK was the traditional format of print for conventional litho print presses and the ilk. So if you go somewhere and you want a magazine printing, it'll be done with cyan, magenta, yellow and black inks. Now, the printer that you have on your desktop is not really a cyan, magenta, yellow and black printer. Yes, it might have cyan, magenta, yellow and black ink in it, or in the case of some of them, a light cyan and a light magenta, or in the case of even more, an 8-colour system with light blacks and light blacks. Now, inherently inside these machines, it has an RGB printer driver. Now, what that means is no matter what you print, it's going to get converted into an RGB colour space. And then when it hits the engine of the printer has inbuilt inside it a colour table to convert it from that RGB back into the colour space of the printer itself. Not CMYK, nothing like CMYK. It's its own cyan, magenta, yellow, black, or its own inbuilt colour system, whatever that may be. Okay, CMYK, CMYK LCLM, CMYK LCLM, LK, LLK, orange, green, you name it. So it bears no resemblance to traditional CMYK. Now CMYK, if you design in CMYK, it's quite a small colour space. So you're going to miss out on a lot of more vibrant, bright colours. And if you create something like a photograph and you print it CMYK, it's going to be muted, it's going to be dull. It's not going to have the punch. So the only time really you should be using CMYK is if it's going to go to production for a long run, something like that. Now even modern digital presses like Xeroxes and Zycons and things which are toner based, they can still work very, very well with an RGB file. And it will utilise the bigger colour space of your printer if you stick an RGB. So if you imagine, if I've got an RGB red, and it's a very, very deep, vibrant red, the CMYK colour space can only make that red out of a solid yellow and a solid magenta of whatever manufacturer's ink the litho press is using. And they're all quite dull compared to inkjet ink, which is a lot more vibrant. Obviously sublimation ink is somewhere in the middle. So if we design as an RGB, and there's two RGBs in main, there's a sRGB and there's an Adobe RGB. Now the Adobe RGB is the bigger of the colour spaces, and that will give you the more vibrant colours. And then there's the sRGB, which will be more closely matched to the colours on your monitor, if it's calibrated. Okay. Some high-end monitors can show you the Adobe colour space. Not a lot of them, but some of them can. So if you design an RGB and you leave it as an RGB file and print as an RGB file to your whatever printer it is, you're going to get a conversion from that RGB into the printer's ink colour space. And that's going to give you the brightest, most vibrant colours that printer can achieve with that ink, that paper, and on that substrate that you're having to press to. Now, not all are the same. So if I go to the shops today and I buy, I don't know, an Epson WF7110, let's say, and I buy two of them and I put them side by side and I print exactly the same file to both machines with exactly the same settings, I will get two slightly different results, because in the factory they're not made to be identical. Like when you go to the higher end machines, tend to be engineered differently, and they're put together, and each high-end machine can be recalibrated. So if you're looking at an Epson 9880 or a 9890 or one of the new P6000, P9000, as an engineer, I can recalibrate those internally to set its color space, so I can have 5 or 6 of them and get them pretty close to each other. Never identical, pretty close. But on desktop machines, it's not like that at all. So a lot of the time when you're printing, it's very much so, oh, let's just like see what it looks like. So the recommendation is to always have a color profile made. And the reason for this is then it's your press, your printer, your ink, with whichever heat settings that you happen to have, and any characteristics that your specific printer has will be reflected in the color profile that's made. Then when you print it, you're going to get the best results that it can. Now, there are going to be some certain colors that you're never going to achieve. I see a lot of people trying to print very, very vibrant, sugary pinks. Very, very difficult. Very difficult indeed to achieve those colors. Now, we do have fluorescent inks and things like that, but I'm going back to the CMYK RGB argument. With a CMYK, if you want to produce a CMYK accurately on an RGB printer, you need to put a bit of software in front of it called a RIP, or a raster image processor. If you don't know what they are, Google things like EFI Fiery XF, Caldera, bits of software like that, which are thousands of pounds, but they actually are very, very accurate in making a printer print exactly the right colours that you require. But they require calibrating on a weekly basis to keep them in specification. A calibration device somewhere in the region of £1,000. So obviously, people doing sublimation mugs at home tend not to bother. So if you want to have a really, really bright, vibrant pink, then we supply a sublimation ink, which is a fluorescent colour. So we've got fluorescent yellows, fluorescent reds, all that sort of thing. But you need a RIP in front of it to drive it. And what a RIP does, a RIP bypasses the RGB driver that's built into your software, like your Mac OS or your Windows OS, and it talks directly to each individual channel on the printer independently of each other. Doesn't let the printer make up the decisions on how it's going to adjust colour. You do that within your software. So it's a much, much more accurate way of producing it and professional. But you tend to find that it's only companies who've got wide format machines, who are spending a reasonable amount of money on them, and who are doing a lot of work, tends to be textiles, that sort of thing, who invest in that sort of product. If you're just using the RGB driver, you really can't start using fluorescent inks or any of those vibrant special colour sublimation or any other inks really. What else can I say about them? So that's essentially why we should design in RGB. By getting, first of all, a bigger colour space. Second of all, it's a smaller file. So if you make a CMYK file in Photoshop at 300 dpi at A4, and you do exactly the same, but as an RGB file at A4, you will notice the CMYK file, although it's a smaller colour space, there's not as much colour in it. It actually takes up more physical megabytes than an RGB file is, because it's got 4 channels, not 3. So stick to RGB. I know RGB can be quite difficult to get your head around if you're a designer and you've designed in CMYK. It's really easy to work out, you know, what percentage of yellow and what percentage of magenta makes a red. But doing it in RGB can be a little bit more difficult. You might just say, oh, I'll put R up to 255. That might give you something that the printer can't achieve. What I suggest you do is take one of the charts. So there's a chart in files called, I think it's color management chart or color chart. Print that to whatever settings you use, press it, and use that as a reference file. You'll see on that chart there's a grid, so going from, I don't know, 1 to 20 or whatever it is, and A to whatever on the other side. And then you, let's say, print a colour and patch number B32 is exactly the colour you want. Open that in Photoshop or whatever, use your eyedropper tool to eyedrop on that colour, and there's your colour palette in RGB telling you exactly what that colour was made out of. So you can reproduce that colour on whatever it is that you're printing, whether it be a mug or whatever. And bear in mind that if I buy a mug from Express, and I buy a mug from Subliblancs, and I buy a mug from Dye Sublimation Supplies, they're all going to be slightly different in their coating. And it's the same thing with the papers. High release papers, you might find that you've printed stuff normally with, I don't know, DinoSub, let's say, but then you've gone and bought Express Premium and you find everything's darker. That's because Express Premium is a high release paper. What high release means, it lets more ink away from the paper into the product, so the product is going to be, you know, more saturated in colour or darker. There's benefits with that. You can actually have a new colour profile made, which reduces the amount of ink that you actually use, because it doesn't need to use as much. And also when you're doing it on garments, the garments look a lot more vibrant. The only other downside is it can sometimes release too much ink. And if you do release too much ink, in clothing in particular, I might find on a first wash, some of that washes out, but it doesn't affect the overall colour of the garment. So I hope this explains why we use RGB and not CMYK when we're printing. Thank you very much.